I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to discuss derivation of sine law and its application. Ambiguous case is slightly tricky. Whenever you are given an acute angle with two other sides, there is possibility of making two triangles for the given dimensions. We will take up an example to make ambiguous cases extremely simple for you. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence, get ready for future. We develop both mathematical and social skills. I can be part of your success story, build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Aaria. Hi Aaria, how are you doing?
Hi, Anil sir. I'm good. How are you?
Very good, very good. So, how was your test?
It was really hard, but it was as good as I could do it. But I'm hoping that the test coming this Friday for Trig goes a lot better. And I'm gonna work with you, and we're gonna go quick, but we're going to go at a good pace. Where we today we're not like doing questions; we're more doing like understanding stuff. So, and same with Monday, and
Sure.
then Wednesday we're gonna do questions.
Perfect.
Get into
So,
it.
we are going to divide this three sessions into one day of degrees, the other day of radians, and then we'll mix them both and then prepare for the test, which will be on Friday for you. Correct? So, let's. So, I'll teach you from very basics. I'll take a whiteboard, simple, and then teach you the concepts. So, can you see my whiteboard?
Um, yes, I can see it now.
Perfect. So we're talking about uh, trigonometric ratios. So let me write in short, trig ratios. You know what sine, cosine, and tan
Yeah.
is. So till now you've been working on a right angle triangle. So let me draw one here. Right, not so good, but I hope it makes sense. Let's say this is A, this is B, and this is C. In that case, the sides will be lowercase a, b, and c. The angles can be referred to with the vertices. So what is sine A equals to? Sine A is
Sine
opposite side,
opposite over hypotenuse.
which is C. And similar, we can write what cos A and tan A can be, right?
Yes.
So in a right angle triangle is not an issue. We can very easily find all the things. And let me just write down A over B now. And from here, you know that tan A basically is equal to what? Sine A over cos A, right?
Oh, because it's opposite over adjacent?
So if you write down this, yeah, so A over C over B over C, what do you get? You get A over B, correct? So we
Yeah.
have just understood our first trigonometric identity, that is tan A or tan theta is sine theta over cos theta. Clear?
Yes.
Simple things which you do is remember using SOHCAHTOA. Sine is opposite over
Yeah.
hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent.
So
That's
our adjacent is like if you have the angle, like for example, if we're looking at angle C, our adjacent will be the line of B, right?
the yes. Adjacent is between the angle and 90 degrees.
Okay.
So if this is the angle, let's say theta, and this is 90 degrees, adjacent, and opposite is right across. So when you look from A to the other side, you see that side A, that is the opposite side. Is that clear to you? So
Yes.
that is how we do it. And let us also understand that if we go slightly beyond this acute angle thing, so on a coordinate plane, you know, if we put the initial arm along the x-axis, right? Let's say this is my initial arm, and the
Mhm.
terminal arm is rotated, then it forms an angle, and this angle is theta. You see that? So that is
Okay.
the terminal angle. Whenever the rotation is counterclockwise, then the angle is positive. If the rotation, this is counterclockwise, right? Then
Mhm.
we'll consider positive angles. But if the rotation is clockwise, then the angles will be considered negative. Is that okay?
Yes.
Now, what I'm trying to say here is that if I have this as 30 degrees, right? Since it is considered clockwise, I'll treat this as minus 30 degrees. Is it okay?
Yeah.
Let's say this angle is 60 degrees. I'll consider this to be positive 60 degrees. Is that okay? Just a nomenclature. Perfect. So this is one thing very important to understand. Another thing is, let me again draw here. I'm just using my space in the best possible way. Let us say I have a circle. Uh, we call this as a unit circle.
Oh, I know this.
You know this, remember, right?
Yeah, it's like the side. It gives you the sides of like the triangle when you like
Yes,
look
yes.
at it. If you
So
have
if
the
this unit circle has a point P, which is x, y, right? In that case, let us say, let us assume unit circle times r for now. I'm making it general.
okay.
Let us say this is r form. Radius is anything r, right? So in that case, we know r will be what? In that case, the radius will be, if I drop a perpendicular from here, then this side is x, the other side is y, and r is equals to x square plus y square square. Is that okay?
Okay.
Now also see that if this angle is theta, then what is sine theta equals to? Opposite side is y, it is y over r, correct?
Yeah.
And cos theta is equals to x over r, and tan theta is equals to ratio of y and x, correct?
Mhm.
Like a slope of this line. You see, OP slope is tan theta. Tan theta is y over r. And if you see, O is the origin. So the coordinate points actually ratio y over x gives you the slope of the line OP. Do you see that? Can you
Yeah.
correlate? So this is slope or the gradient.
Oh. So if they
So
were to ask, like, they give us a point and then they're like, okay, here's
what is the
theta,
gradient? Yeah.
here's another point, they ask what's the gradient of this line, then you should use like if your angle is this way, then it should be the tan of the line because it gives
Tan
you the
theta. So this is the same as value of m when you find gradient of a line,
I
where
see.
theta is the angle which the line makes with the x-axis. Theta is the angle which the line makes with x-axis. You get the idea now?
Yeah.
So, so that is how you can also find gradient. So immediately we have jumped into the next level where we have related trigonometry with the linear equations you had learned. You see the translation, correct?
Yeah.
Let me now also relate the Cartesian plane with our trigonometric unit circle. Now, if I make r as equal to 1, then what happens? If I write r equals to 1, then sine theta is what?
Sine theta is y
Y,
over
r is
cos.
1, cos
Oh, yeah.
theta will be equals to x. You get the idea. So if I
Yeah.
have a unit circle, then the coordinate point represents the value cos theta sine theta.
Oh.
Very important to understand. The coordinate point actually represents sine theta cos theta if I'm considering the r as 1. You get
Okay.
you get the idea, right?
Yeah. I
If I
kind of get it.
normalize it, you understand, right?
Yeah.
Even if it is, let us say we give you some value which is 8 and 6. I know 8 square plus 6 square is not 1, it is 100. But then divide by 100 will give you 1, right?
Yeah.
So straight away we get the value sine theta and cosine theta from the coordinate point also. You get the idea.
So if the radius is 1
Yes.
of the unit circle, then our sine theta equals to our y coordinate and the cos theta equals to our x coordinate.
Perfect.
Okay.
That is what is the importance of unit circles in trigonometry. Right? It directly gives you the value sine theta and cos theta. So you have understood that the x value represents cos theta and y value represents the sine theta, correct?
Yeah.
Beauty of this is this. You have heard about the cast rule?
Yeah, I
You,
did.
now see this cast rule, CAST. Unfortunately, we are starting from quadrant 4. C is placed there. But look here. A means all positive. All trigonometric ratios positive. Because in quadrant 1, x and y both are positive, correct?
Okay.
So, since x and y means sine theta and cosine theta are positive, their ratio will be also positive, tan theta, correct?
Okay. I think when we learned cast rule, I think the A stood for like anything, right? So like any value would like be positive in the A quadrant.
Yeah. So, we are looking into primary trigonometric ratios, sine,
Okay.
cosine, and tan, right?
Yeah, we haven't learned the other ones yet.
Yeah. So, others are reciprocal, don't worry. Primary trig ratios, right?
Yeah.
So, these primary trig ratios are all positive in quadrant 1 since x and y values are positive. So, try to relate with x and y value. It'll be easy for you.
Okay.
But in quadrant 2, any point if you take, x value is negative, y is positive, right?
Yes.
So therefore, y relates to sine and therefore sine is positive, cosine is negative.
No, I'm confused.
Okay, let me make a fresh page to explain the cast rule, right? So now we are talking about the cast
Okay.
rule. Let's take some coordinate points here. Let's say this point is for us, let's say 3, 5, right? Just general, right? So here some coordinate point, let's say -4 and that say 4 is okay. So here let me take a, both will be negative here, right? So let's say -3, -4, is it okay? So here both, one will be, x is positive, right? So let's say 5 and let's say 2 values. So let's say we have a coordinate point here. Is it okay?
One will be negative though, so it'd be -2.
You are right. So negative. Good job. You're paying attention. Perfect. Now, since I say that my x and y values actually correspond to what? Sine theta. Oh, sorry.
Sine theta. It's
Cosine.
cos theta, sine theta,
Yes.
because sine theta is your y and cos theta is your x when the radius is 1.
So in this quadrant, you see all are positive because sine and cosine both are positive. In
Okay.
this, what is positive? Only
Sine is
sine.
positive, but cos is negative. Oh, that's the sine quadrant.
Yeah. And here,
Okay,
both are
okay.
negative. Means sine and cosine both are negative. So
Because
their
it's the
ratio is
tan
positive.
one. Oh, this makes so much more sense.
And here,
Your cos is positive, but your sine is negative.
that is the cast rule.
Oh, okay, that makes so much more sense.
Can you relate it very easily with coordinate points? So simple as that. And
Yeah.
when we talk about unit circle, don't make a circle. Just take a very simple point, right? I could take a point. Why am I taking +3, -3, all those things? Oh, come on. Let me take this point as 1, 0, right?
Okay.
And this point 0, 1, right? This point -1, 0, right? And this point 0, -1, correct?
Hmm.
So now this time I have not taken points in the coordinate, I have taken points on the axis itself, not in the quadrants. So when we
Okay.
talk about the quadrants, then the axis is like ambiguity. You don't know which
Yeah.
quadrant I will consider this axis.
Yeah.
So we are saying this is quadrant 1, right? And this is
Yeah.
quadrant 2, this is quadrant 3, and this is quadrant 4. All of a
Okay.
sudden, the point lies on the axis itself. Then consider point 1, 0 or 0, 1 or this combination. Unit away from. So we are now considering points which are unit away from origin.
Oh yeah, because they're one away, negative
One
one away.
away, right? If it
One,
is
yeah,
on the
yeah.
right side, it is positive. If it is on the left side, it is
Side is
negative.
negative.
If it
Yeah.
is above, it is positive. If it is below, it is negative. Is
Okay.
that clear to you?
Yeah,
But
that's clear. Yeah.
now see the angle. This is 0 degrees and this is 90 degrees. This is 180 degrees, correct? And this
And
is
that's
270
360.
degrees. And this
Oh,
is also considered as 360 degrees, correct? You know sine value corresponds to y value, cosine value corresponds to x value. So
yes.
for 0 degrees, cos is 1, sine is 0. Do you see that? Cos
Yeah.
1, sine. For 90 degrees, Cos is 0, sine is 1.
Yeah. Oh yeah, because I told you sine of 90 is 1 at the beginning of the video.
For 180 degrees, minus 1 is
Cos
cosine
of -1 is
and
0.
0 is sine. And for
Yeah.
270 degrees, 0 is cosine and minus 1 is sine. And for
Mhm.
360 degrees, again, cosine is 1 and sine is 0. So you all of a sudden get all the points in your mind just by looking at this coordinate plane. Does it make sense to you?
Yeah.
So if I ask you, what is sine of 270? You will see sine of 270 should be minus 1.
And
Get the
then the
idea?
cos of 270 is 0.
Done. So whenever it comes to 0, 90 or the multiples of 90, only look for 1001 combination of points, knowing fully well that x gives you cosine and y gives you sine, and the ratio of sine and cosine is tangent, you
Mhm.
get all the values. Is that clear?
Yes.
So here we have reviewed the points which are unit distance plus any point in the quadrant plane. If it is in quadrant 1, all are positive. 2, sine is positive. 3, tan is positive. And in 4, cosine is positive. Is that clear to you?
Yes.
Perfect. So let's move forward from here. This is all known to us now. We'll take up an example where the triangle is this time not a right angle triangle. So then how am I going to solve this triangle with trigonometric ratios? So I have this triangle, which is not a right angle triangle. So I'm again labeling this as A, B, and C.
Is this where you use the laws?
Yes, yes.
Okay. I think if you write the units, I want to see if I can walk you through and see if I get it.
Let me write
So
B here this time. Okay. Now the idea here is that let us say if this side is 4 and this side is let's say 10, then how do you find the other side? Or if I give you this angle something, if I give you some other thing also, for example, if I give you this angle and let us say some 30 degrees, for example, how do you find the other side? Now
you
this is
use
not a right
sine.
angle triangle.
You
How
use
will
sine.
you can use sine? But let us now try to derive a formula to figure this out. Is it okay?
Yeah.
So what I will do is I'll take a general case. So
I'm gonna
general
draw this.
case,
1 second.
yeah. So general case will be I'm saying this is let's say A and this is B and this is C. So
Okay.
whenever you have a triangle with vertices A, B, C, sides opposite will be in lowercase, correct? So to solve, let me drop a perpendicular from this. So if I drop a perpendicular, I all of a sudden get two right angles, right? So instead of one, we have two right angles. Good job. So how do we work with this? Right. So we say, well, let this height or altitude of this be h. And now, can you tell me what is sine of A equals to?
Sine of A equals to H over
B.
AC.
B, right? AC, which is B. And what is sine of B equals to?
Sine of B equals to H over B.
So we are looking into this triangle now. So here the
Oh,
hypotenuse is
A.
A.
It's A. Yeah.
So let us rearrange these. So what do you get? From the first one, you get cross multiply. B times sine A is equal to H, right? Cross multiply, correct? Is that clear?
That's the formula I said for the ambiguous case.
Okay, we'll see that later. You're going so fast. Here, we'll cross multiply, we get A times sine B is equal to what? H, correct?
Yeah.
So we got two equations and both are giving me value of H. Why not substitute? So we get what? From here, these two equations, what do we get? We get H is actually equal to B sine A and it is also equals to A sine B. Okay, let me cross multiply. So I could write B over sine B equals to A over sine A. Do you see that? So I have all of a sudden written my sides as a ratio of sine angles, correct?
Yeah. So basically, you derive the sine formula through
Sine law. Yeah,
primary. Ratios.
Yes, simple.
Oh.
If I would have drawn this perpendicular to the other side, I would have got C involved in it, right? So I'll also get C over sine C. Is that okay?
Yeah.
Which is a constant K, okay? So this is a ratio which is always constant, and this is called sine law. It can also be written as sine B over B. I mean, you could write A first or B first, doesn't matter.
Does that tell like if we need to solve for like the angle, then you put it on the top, and if you need to sign for like the solve for like the length,
Simple.
you put the little letter on the top?
Correct. That is how you're going to do it. Does it make sense to you?
Yeah, I
Hmm.
see how you derived it through
Yeah.
like the H. Yeah.
So simple, correct? Now,
Yeah.
based on this, we can actually solve many questions, right? So that means now we can solve any triangle, not just a right angle triangle, correct?
Yes.
Perfect. So we'll erase this, make a note of this, and then we'll move forward from here.
I wrote it down.
Great job. Now, there are many examples which we can take. They are relatively simple examples, but let me tell you one very important thing in this sine law. Let's rewrite. So we have sine A over A equals to sine B over B equals to sine C over C, right? So you can solve many triangles, but not all. For example, if I give you a triangle in which I give you three sides, for example, right? So let's say my sides are uh, 10, 12, and 13, for example, right? So I cannot solve this triangle since I don't have any angle combination. You get the idea?
Mm.
So it is important to use sine law. If you want to use sine law, then it is important that you have at least one combination of angle with opposite side.
So like the side angle pair, right?
Side angle pair. Right. So let me write side angle pair. You use better terms.
They're not mine. They're just what I've heard.
Good job. So you should have side angle pair to solve any triangle. Is it okay now? Correct?
Yes.
Perfect. We'll move forward from here. We'll come back to all these together with few examples. Now let us talk about something more about it, right? Let's say, uh, let me again make this triangle. One of the most important examples which we come across in sine law is ambiguous case. Now, where I find some students getting confused about it. So we had all this, right?
Yeah.
A, B, C. Okay, great. And then this is D, which is perpendicular. Now, if I give you the side length, which is B and A, and I give you this angle, which is angle A. So if angle A is given to you, and side B is given, and A is given, then you solve this using sine law? Because we do have a combination, right?
Yeah.
What do you call this? Side angle, right?
Yeah, it's the side angle
Combination.
or angle side, however you want to say it.
Yes, combination. So you could apply the sine law to answer this question, correct?
Yes.
Now look here. If I say that angle A is equal to, let us say 40 degrees, and B is, let us say, equal to 10 centimeters, and in that case, will any value of A make a triangle?
No,
That
it
is
has to be bigger than
CD,
the
right?
length. Yeah.
CD. It has to be bigger.
Otherwise,
Because
it won't close,
yes,
right?
if let us say A is smaller, right? Only that much long, then it cannot form a triangle. You get the
Mm.
idea. So, what is the minimum length of A? Let's figure this out. To form triangle. Can you work this out?
Yes. So we're given angle A.
40 degrees.
40
and B
degrees,
is
and we're
10
given
centimeters.
B is 10 centimeters, and we're given that. Don't we need another side though to find?
Yeah. We'll find minimum length of the side that will form one triangle. So that one
Oh,
triangle,
we
yeah,
have 90 degrees.
yeah, we have 90 degrees.
We
You
have the 90 degrees, and the 90
correct.
degrees goes both ways. So we can go 180.
Sine, yeah. So
90
sine of
plus.
A is equal to the minimum difference is height
Yeah.
over B, right? So we
Yeah.
have this, we know all this. So height is what we are looking for, which is B times sine A, right?
Yeah.
And B is 10 and sine of 40 degrees. Can you please calculate and tell me what is this height?
Sine of 40.
10 times sine 40.
It is 6.43.
6.43, right? So that means if A is equal to 6.43, I make one right triangle. Is that okay?
Yes.
Now, and B is 10. If A is 7, then what happens? More than 6.93, then what happens? This is what we have to figure out. Well, if it is more than this, means that long, in that case, we can form two triangles. Do you see that?
Yeah.
One this and the other one this one. Do you get the idea?
Oh, that's what my teacher was trying to show today with the lines. I just didn't understand because she did so many of the lines. Oh, okay, I get it. That makes so much sense.
So this gives you a very beautiful condition
Yeah.
that A should be at least greater than the height. And what is height? Height is B sine A. Do you see
Sine.
understand? So
Yeah.
height H is B sine A. Remember that part. So B times sine of this angle is the height. My side A should be greater than B sine A, right?
So is A like the hypotenuse of like
No.
the
For the smaller, for the other triangle, yes. For one triangle, if you split with the height, then it is. Not otherwise.
Okay.
Now look here.
Okay.
A is the length of a shorter side if it forms a right triangle. That means only one triangle is formed. But
Okay.
if A is greater than height, then two can be formed. Imagine A equals to 11 centimeter. Then what happens?
Then you can get 2, right?
No, 11 means from here, A is 11 means it is even longer than this. Do you see it will go here?
Yeah. Oh, so it has to be less than B to form one triangle.
Yeah, it has to be less than B.
Otherwise,
After
it'll be too long and it won't like close.
it won't close. Then you know what? If this is acute angle, correct? If this is acute angle, the side has to be smaller,
Oh yeah, because it's opposite.
at least one side, right?
Yeah.
And you see, bigger unless and anyway. So if we have this triangle, and if A is longer than B, then you cannot make two. You get the idea because this acute angle is limited.
Okay.
So you could make one. Not this is not formed. Do you see that? You have the other one. Let's,
So
let's go
the,
back to a new page.
what's the condition then?
Let me because there's less
Okay.
space.
Yeah.
Let me make smaller diagram so it's easy for me to put all the things on one page.
Okay.
And there we go with right angles
I
AB.
get that if our A value is greater than our like height value, which is like B sine A. So if we were to like, find B sine A first and then we compare that to our A value, then we can figure out like the condition of it. Like we can prove that it can make two triangles.
So we are considering angle A is acute angle. Very important. Is it okay?
For this case, is the angle that is given always acute, or does it depend?
Yes, always acute.
Okay.
For this case, always acute. Right. So we are given acute angle and we are given angle side side. So we given angle and two sides. And we want to know how many triangles can be formed. That is my question. Is that clear to you?
Yes.
So we look at it like this. If first thing is find minimum height minimum length of that third side, which will form a triangle. That is the height of the triangle, correct? So height of the triangle is b sine a. So we come to a conclusion that a should be greater than b sine a. Is it okay?
Mhm. To
And
form.
second condition is that a should be less than b. In that case, we form two triangles
Okay.
less than b. Because if it is
So
greater than b sine a, then we came to a conclusion b sine a is the height, so it will make like this. Do you understand?
okay, I get it. So if our A value is greater than the height, but is also less than B, that's the only way that we can
Two
get two
triangles.
triangles.
Right. Now let's look into the second case. So let me draw independently instead of messing it up, right? Now in this case again, we have this condition, and now let us say we know this is like very important to understand. That's why I want to take some time here. Now let us say that A is greater than B, right? If A is greater than B, like shown here, right? In that case, can you move with this angle of acute angle? Can you make up another triangle? No, because it should intersect on right hand side of this angle, correct?
Can only make one.
One triangle.
Oh, so that's the other condition. I see.
So you have to check with B sine, right? And of course, third condition we figured out earlier, and that is
Oh, if the A value is equal to the height value, then it can also make one triangle, right?
yes, yes, yes. Correct?
Yeah.
And
This doesn't seem
and
that
if
hard
A
though.
is less than B sine, yeah,
This isn't that confusing.
yeah, yeah, no triangle.
Oh, okay. Yeah, we discussed that because if the
Yeah, we
A is
discussed that. If
smaller, then
A
it
is
can't
only
close.
this much, right?
Yeah.
So I don't
So
have space to draw it, but I drawn it earlier. So
is that
now,
the only time that like like there's no triangle formed is like if
yeah,
the A is like larger? Okay.
correct. Last time we found a value of 6.23. If I say A is 5, then no triangle. Is that okay? So
Yeah.
looking into our values, we say B equals to 10 and let's say angle A equals to 40 degrees. So we found that A equals to 6 point, let's say 2, whatever, 2, 3. We
Mhm.
get only one triangle, correct?
Yeah.
If I make it 2, then we get two triangles. I mean 7. A equals 7, then two triangles. But if I make A as only 6, then zero triangles, correct?
Yeah, because
But
it's
if I
smaller.
make A as 11, then one triangle. You get all the conditions now?
Yeah, I get it.
You understand?
Yeah, I get
So,
it.
yeah. So whenever you're given acute angle and two other sides, in that case, make a triangle as shown here. Put that given angle as A and compare B sine A with the third side A. A should be definitely less than B to try it out. If A is greater than B, there is only one triangle. Is that okay?
Hmm.
But if A is equal to B sine A, then again one triangle, and that too a right angle triangle. So you'll get the angle also directly. Is it okay? But
Yeah.
if A is between the height and B, then you can make two triangles, and this is what is called ambiguous case.
Oh, because there's so many options. Is that why?
Two options. And basically, solving a triangle basically means find its sides and angles. So in this case, since there are two triangles, when we calculate using sine law, we find one angle, for example, right?
Yeah.
Considering that to be the triangle, right? So this is, one. Let me make a new diagram to show you this part. Is it okay?
Okay.
You like it? Okay. So let me just draw one triangle. So I'm assuming that this side is shorter than the other side. Doesn't look like though. Let me erase this and make it realistic.
Draw a scalene triangle.
So instead of doing like this, what I'm doing is, you see that I'm using this
Oh, okay.
reverse calculation.
I see what
So,
you did.
so what I've done here is I know some calculations we did, right? We'll go with this
40. Yeah.
It's easy for us to, right? Let
Yeah.
us assume that this here is 8 centimeters, right?
Okay.
So 8 centimeters, and we know this was 6.2, right? To make a
Yeah, it
right
was
angle
6
triangle.
point. Yeah, it was 6 point 4
Oh,
3.
6.4. We know that is the height. Definitely 8 is is actually greater than height and it is less than 10. And therefore, we know we have two triangles. Is that okay?
Yeah.
Now you have to solve for these two triangles. How will you solve? So, sorry, this
I've used sine law.
right. So you will use sine law. Let us use sine law and solve it.
Which angles do we want to find? This
We'll
angle.
find angle B.
Okay. So what I would do first is that we know that we have a 90-degree angle right
No, no,
here.
no. Just go for scalene triangle, bigger one, and
Oh,
apply the sine law in triangle ABC, right? We
okay.
have to find angle B. So put sine B
So
on top.
you have sine of 40 over um 8,
Correct.
and sine of 10 over b. Yeah, sine b over 10. Yes.
So
And then
cross
you do sine
multiply, right? So
40 times 10 and then over 8.
calculate. What
You're
do you?
so fast. You just start writing before I even say it.
Yeah, yeah. Calculate.
I'm like midway thinking, this one's almost done.
And don't erase the answer of that degree, whatever you get number.
Okay.
So sine 40 times 10 divided by 8.
Okay, let me just do 10 times sine 40 divided by 8. So that's
Redo. No, no, no.
0.8035.
Wrong answer.
No?
Redo. You divided the product with, you did sine 40 divided by 8. No, no. Do sine 40 equal to times 10 divided by 8.
Oh, you want me to do? Okay. I just did everything in one line.
No, you did. I'll tell you what you did. You did 10 sine 40 divided by 8. You know what you did? You did this.
Oh, oh, oops. So sine of 40 is 0.6427.
Times 10 divided by.
And now I'm gonna times it by 10, which is
Yeah.
6.4278, whatever. Divided by 8 is 0.80348.
Whatever. And do sine inverse of that. So you
Okay.
get B.
Let me just write it down.
Yeah, write down.
0.035. And then sine inverse is shift sine -1, 0.8035. It's 53.45. 47.
Let's tell me again. What did you get? Sine B is equal to 0 point?
0.8 035.
Correct. So sine inverse of 0.8035 you did and you got the angle of 53.47, right? That really means you calculated this angle as 53 degrees, 53.5 degrees, let us say. Is it okay? Rounding.
Yeah.
Now, if that is 53.5, and we know these two, that we have made one triangle, we know we have two triangles. So the other triangle will give me B dash here. You get the idea?
Okay.
So the other triangle will have this angle as B, right? Not that.
Yeah.
So this angle will be how much?
It's
The other
180
angle
minus 53.5.
yes, 53.
Because when you have sine, then you have like the first angle being the acute angle, but then because that's in the first quadrant, and then when you go to the second quadrant, it becomes obtuse because you do 180. So you have to do 180 minus that.
Another thing, because this is an isosceles triangle, this angle is equal to B, and that has to be 180 minus B. You see that?
Yeah.
So 180 minus 53.5, how much do you get?
I get 126.5 degrees.
Very good. So, couple of ways to look into this. Whenever we apply the sine law, we are actually thinking in quadrant 1, correct? We are
Yes.
always thinking in quadrant 1, and whatever we get, we got 53 something. That was a solution of our question, where the angle was calculated here. But you remember the cast rule. Cast rule says that sine positive means you could be in quadrant 2 also, right?
Yeah.
So with the same acute angle, there was another answer, which is 180 minus theta, which is also your answer. You get the idea? So when you get sine, when you get some angle theta as, let us say, sine of 0.8, for example, in that case, you are actually looking at two solutions, right?
Yeah.
One in quadrant 1
One
and
and
the
the
other one
other
in
in
quadrant
quadrant
2,
2. Because you
right?
have two triangles.
They're
That's why.
complementary pairs.
Yeah.
Supplementary pairs. And so the other angle is 180 minus that. Is that clear to you? So you all of a sudden have figured out both the angles, B and B dash, the other being 180 minus this. Now the second exercise is you have to now find the length A to B dash, correct?
Okay.
And also you have to find the length A to B, right? So
Yeah.
both these lengths you have to find A to B. So A to B you can find using sine law, right?
Fine. Oh, yeah.
So figure this out. A to B will AB over the angle which is opposite to this. So what is this angle? 180 minus what? A minus 53.5, right?
Yeah. Because our B angle is 40.
Correct.
Okay.
So how much is that?
That is 180 minus 40 minus 53.5 is 86.5.
So you know this and you are given this combination which is 8 over sine of 40, correct?
Mm.
So from here you can find what AB is, correct?
Okay.
So you have solved one triangle, which is the bigger triangle. Now do the same calculation for the smaller triangle, ACB dash, and also find AB dash. Then only the question is completed. So you have to solve for both the triangles.
Well, you can use sine 53.5 for the B prime C
Yeah,
angle.
yeah, this angle will be, yeah. So you
Because
have to
that's
find this,
opposite.
yeah, this acute angle will be 180 minus 40
180
minus
minus 40 minus
this
your
angle,
126.5.
126.5. And then do the same calculation, find AB dash. You get the idea? So
Yeah.
whenever you have an ambiguous case, you have to solve for two different triangles and write complete solution. Then only get full marks. This is ambiguous case. Have you understood this completely?
Yes, completely.
Good. This is the most difficult part, right? I will quickly teach you one more thing, and that is, and then I'll end today's lesson. And
Okay.
that is very important formula, and that is to find area of a triangle.
Oh, is it the half
AB sine.
AB sine C?
Yes. So I'll quickly do that. How do
Okay.
we get it? We are almost there. So okay, let's say this is my angle, right? Let us say that we are now given two sides, right? So sides given to us is, let us say we are given these two sides, side. I'll redraw it. I want to use AB sine C. Okay, so side, this is A for us, right? And it doesn't really matter. So AB. We are using this angle, okay? So what is the area of triangle? Area of triangle is half base into height, right? So in this triangle, what is the base? Base is B, right?
Yeah.
And what is the height? In
It's
terms of angle C, we can find height as
H. So it's sine B sine A.
A sine C, right? We are looking into this sine.
Oh yeah, A sine C.
Remember, sine is always less than 1 and height has to be less than hypotenuse. So we have to multiply A with sine C. It is easy way of remembering. You get the idea.
Yeah.
So area of the triangle will be what? Half of base, which is B, times A sine C. Very good formula to find area of a triangle if you are given two sides and included angle. Is that clear to you?
Mhm.
So you can solve many questions where you are given, let us say we have a flower bed in which the two sides are 10 and 9 and the included angle between them is, let us say, 70 degrees. What is the area of the triangle formed?
Oh, that was one of my questions.
Your question was three sides given. We'll take this up next class. Cosine
Okay,
law. Okay.
that's good.
So I hope this part is clear. We'll take up from here in the next class, right?
Sounds good.
I'll share with you more videos on that so that you can do some of your questions which you need to do. We could cover only half of it, what we decided to do, right?
Yeah.
So anyway, so I'll share with you some videos which will help you answer the rest of the questions, correct?
Correct.
Okay, then we'll end the class. I'd like you to summarize today's learning. So what did you learn today?
So we learned how to like derive the cast rule, and we understood that sine theta equals to your y value, and cos theta equals to your x value only when your radius is 1,
Okay,
and
unit circle.
well, like during with your unit circle. And then we learned the sine formula and how it's derived from like primary trig ratios when you have like sine a over a equals sine b over b equals sine c over c, and you can like exchange those values, like turn the denominators into the numerators, if you want to like solve for like an angle or if you want to solve for like a side. And then we learned an ambiguous case, meaning that you can have like a triangle that can make two triangles, and that's there's like a few conditions to it. So the two conditions that make like the two triangles is when your A length is greater than your B length, and your A length is greater than your B sine A length,
Okay.
which is your height. And if your A is less than your B, then that can't make a no,
Height.
it makes if your
Always
height,
compared with height. And remember, height is b sine theta, correct? Height
yeah.
is b sine theta. So you use, instead of using b sine theta, which normally is used in the books, use
Mhm.
height. So if it is
Okay.
clear, you're comparing with the height. If it is less than the height, you cannot make a triangle. If it is equal to the height, you will make a right angle triangle. If it is greater than the height but less than the other side,
Then you
then
make
you make
one
two
triangle.
triangles. If it is
Oh,
greater than
make
the
two.
other side, you don't have to check anything. You'll make one triangle. Simple as that.
Okay. Okay. And then we learned like the area of like a triangle using sine,
Yes.
which is half sine
AB.
half a times b sine c.
Correct. A, B, sine, C. So it gives you everything in a circle, and
Yeah.
that is where we are going to close the class today. Try as many questions as you can, and I'll share some videos so that you can move forward, and
Yeah.
we'll cover up most of the other things in the next class. Okay.
Yeah.
Okay. Great.
Thank you.
Thank you. Bye.
Bye, no sir.